right, gentlemen. We're kind of jumping around in the book, and I apologize for not going in perfect order. But I feel that the order that we have been learning is the proper order that we should be learning these things in. We just finished learning all about rational equations, expressions, and inequalities, and now we're going to go on into root and radical expressions, okay? It's actually radical expressions. Roots is how you get to the bottom line of a radical. So for radical expressions, it's actually quite simple as long as you know how to multiply. And I'm not being facetious. If you know how to multiply, this is going to be very simple. If you don't have your timetables perfectly memorized, this is going to be very difficult. So I definitely suggest you work on your multiplication skills, please, because it will behoove you, will benefit you. Today we'll be learning how to find the nth root of a number. Before we move forward, though, let's go back in time a little bit. Let's try to go back and remember that 5 squared equals 25, right? So we could say that 5 is the square root of 25. Because if I take the square root of 25, it equals 5, right? All right. 5 cubed equals 125. So 5 is the cube root of 125. 5 to the 4th power is 625. 5 is the 4th root of 625. When we're talking about roots, guys, we're talking about the powers. And we're talking about sets of numbers. When I'm talking about a square root, when I say what's the square root of 25, it equals 5 because of one thing and one thing only. If I break down 25, doesn't that equal 5 times 5 to get me 25? When I'm working with a square root, there's an invisible 2 here, right? This invisible number here, which is called the index, and we'll get into that in a second, that tells you the total, the size of the set that you're looking for. In this particular case, since it's a square root, I'm looking for sets of 2. Every set of 2 comes out as one value. So I have 1, 2 5s, it comes out as 1 5. When I'm doing the cube root of 125, I'm looking for sets of 3. Well, 5 times 5 times 5 is 25. 1, 2, 3 5s, that's one set of 3 5s, comes out as a 5. When I'm doing the 4th root of 625, I'm looking for sets of 4. So this would be 5 times 5 times 5 times 5. 1, 2, 3, 4 5s comes out as one value. Okay? I know that you never got that deep into this, but I know that you did, for example, square root of 81 equals 9, right? Why does it equal 9? Because 9 times 9, and we're looking for sets of 2, so 2 9s comes out as 1 9. Does that initial setup make sense to you guys so far? Yes? Okay. Alrighty. So anyways. So let's break this down. If I have a to an n power, that equals b, okay? With a and b as real numbers, and n is a positive integer, then a is an nth root of b. If n is odd, there is one real nth root of b, denoted in the radical form, the nth root of b. I'll explain all of this in more detail in a second. If n is even, when b is positive, whoa, why is this not, hold on. Can't read that. It's kind of hard to read like that. Oh, but why would it be zooming? Yeah, no, hold on. Hold on. I'm messing this all up. Hold on. Give me a sec. I'm going to pause it now. Okay, guys. Now, sorry about that. So let's get back to this. Okay. So if n is odd, okay, if the root is odd, there is one real nth root of b, denoted by radical form as nth root of b. Okay, what am I talking about? I'm talking about this. If I have, for example, the cube root of 8, what would that be? 2. Guys, what if I had the cube root of negative 8? It'd be negative 2. Very good. When it's odd, okay, when my n is odd, I can have positive or negative answers come out. Doesn't really matter. Okay? I can have positive or negative answers come out. Because it's legal, mathematically legal. Now, if n is even, it's different. And b is positive, okay? There are two real n roots of b. A positive root and a negative root. And the negative root is its opposite, or negative nth root of b. When b is negative, there are no real nth roots of b. What the heck am I talking about? If I have the square root of 25, okay? This really equals plus or minus 5. Why? Very good. 5 times 5 is 25, but so is negative 5 times negative 5 is 25. If I have a b that's negative and an even root, square root of negative 4, is that possible? Actually, it is, but it's called a complex number. It would be 2i, but we're not there yet. So this would be no real solution. Because what's 2 times 2? What's negative 2 times negative 2? It's never going to be negative 4. See what I'm saying, guys? So that will never be the case. So, you can use radical signs to indicate a root. The number under the radical sign is the radicand. The index gives the degree of the root. So when you have a radical like this, guys, n here is your index. That is going to tell you how large of a set you're looking for. The value inside of the radical is called the radicand. And the sign itself is called a radical sign. Okay? And again, the index is going to tell you the size of the set that you're looking for. If you have a cube root, you're looking for sets of 3. If you have a 4th root, you're looking for sets of 4. If you have an 8th root, you're looking for sets of 8. If you just straight up have a radical sign and you do not see a visible root or index, that means that it's going to be 2. It's a square root. Okay? If there is no index, then it is a square root. Index equals 2 when it's blank. Yes, sir. Because you have a positive and a negative root, remember? When I have square root of 25, my brother, I can ask for the positive or negative root. The positive root of square root of 25 is just going to be straight up 5. The negative root will be negative 5.
So whichever.
Correct, my brother. Correct. If it says like this, what's negative square root of 25? That's my answer. If I just leave it like this, usually on SATs and ACTs, they just want the positive one. If I go like this, I want both of them. Or I could say to you, find all roots of the square root of 25. And then it'd be positive and negative 5. Thank you, son. Does that make sense? Okay. All right. So that's that first slide. Now, when you are finding real roots of a number, use the index to determine how many values are needed to pull out one of that value. In other words, what is the size of the set that they're looking for? Here is square root of 25. We already did this. This is a 5 times a 5. I'm looking for sets of 2. 2 5s, doom, it's done. Now, let me just show you. If I did 125 square root, check this out. This is 5 times 5 times another 5. A 5 and a 5 comes out as 1 5. But I still have a 5 left over. So what do I do with that? Stays inside the radical. In this case, I have a square root of 125. I can only pull out sets of 2. 5 times 5 times 5 is 125. A 5 and a 5, that's one set of 2, came outside. Whatever I have left over stays inside of the radical. Sir? Correct. If I did cube root of 125, now that's 5 times 5 times 5. 1, 2, 3. One set of 3 comes out as 1 5. This will never be negative in here. For now. Yes. Yes. Correct. Let's what my boys asking. Look, how about this? Let's say I did this, guys. Square root of 45. This is going to break up into 9 times 5. 9 breaks up into 3 times 3, right? A 3 and a 3 comes out as 1 3, and I have 1 5 left over. If I had another 5 there, then it'd be whatever. Or let's say I had another 4, then it'd be square root of 20. Okay? All right, so what are the real cube roots of each of the following numbers? So when I have 0.008, what is the cube root of 0.008? Very good. That's fantastic, guys. This breaks down. You got to break it down. This is going to be 0.2 times 0.2 times 0.2. 1, 2, 3.2s comes out as 0.2. Done. What is the cube root of negative 1,000? That's going to equal negative 10. Because negative 10 times negative 10 is 100. Times negative 10 is negative 1,000. So there's a set of 3 negative 10s that comes out as one value. What would the cube root of 1 over 27 be? This is going to be 1/3. Because 27 breaks down into 3 times 3 times 3. One set of 3 comes out as one of those values. That makes sense so far? Yes, sir. The index is not going to be negative. If the index is odd, the b can be negative. If I have the odd negative 8, yes, this would be negative 2. Okay? All right, give me 1 second, guys.